Hello and welcome to Sort of Such classes. Today we are discussing the JNU paper. This question gives us an infinite series which is extending up to infinity, and we are asked to find the sum of this series. Now, we know that log of 1 plus x can be expanded in the Taylor series in the form of x minus x squared by 2 plus x cubed by 3 minus x4 by 4 plus x5 by 5 minus x6 by 6 plus x7 by 7 all the way up to infinity. So we can write, in place of x, we can write half. That means ln of 1 plus half will be equal to half minus 1 by 2 into 2 square plus 1 by 3 into 2 cube. 2 cube can be written as 2 into 2 square minus 1 by 4 into 2 to the power 4 plus 1 by 5 into 2 to the power 5. So 2 to the power 5 can be written as 5 into 2 into 2 to the power 4, and so on up to infinity. So this is equal to half minus 1 by 2 into 2 square plus 1 by 3 into 2 into 4 minus 1 by 4 into 2 to the power 4 plus 1 by 5 into 2 into 4 square minus up to infinity. This is ln of 1 plus half, and ln of 1 minus half can be written as minus half minus 1 by 2 into 2 square minus 1 by 3 into 2 into 2 square minus 1 by 4 into 2 to the power 4 minus 1 by 5 into 2 into 2 to the power 4 all the way up to infinity. So now this can be further simplified as minus half minus 1 by 2 into 2 square minus 1 by 3 into 2 into 4 minus 1 by 4 into 2 to the power 4 minus 1 by 5 into 2 into 2 into 4 square minus all the way up to infinity. So now if I add the two series that I just wrote, which are ln of 1 plus half and ln of 1 minus half, then we will get ln of 1 plus half means 3 by 2 minus ln of 1 minus half means half is equal to half minus of minus half. So I'm subtracting the second series from the first series. So half minus of minus half is 1 minus 1 by 2 into 2 square minus of minus 1 by 2 into 2 square will cancel out. Next, 1 by 3 into 2 into 4 minus of 1 by 3 into 2 into 4 means 2 into 2 in 2 times 1 by 3 into 2 into 4, which is 1 by 3 into 4. So Next, 1 by 4 into 2 to the power 4 with a negative sign, and here also with a negative sign, so subtracting will cancel them out. So every even power of 2 is getting cancelled out and the odd powers will remain. So next one would be 1 by 5 into 2 into 4 square minus of 1 by 5 into 2 into 4 square would be 2 times 1 by 5 into 2 into 4 square. So again this will cancel. So this will continue. So this will, the next term will be 2 into 7 into 2 into 4 cube and so on up to infinity. So ln of 3 by 2 minus ln of half means ln of 3 by 2 over 1 by 2, which is ln 3, and this is equal to 1 plus 1 by 3 into 4 plus 1 by 5 into 4 square plus 1 by 7 into 4 cube plus all the way up to infinity. And this is the series that has been given to us. This is the series that has been given to us. So we can straight away write that S, which is the series given to us, this is equal to S, is equal to ln 3. ln 3. So therefore, the first option, which is option 1, is the correct choice. In the next question, we are given an expression c to the power 1 minus theta minus 1 by 1 minus theta, and we are asked to find the limit of this as theta tends to 1. So we can write 1 minus theta is equal to x. So as theta tends to 1, x tends to 0. So we can write the limit of the given function as limit x tending to 0 c to the power x minus 1 over x. So we can clearly see that if we substitute the value of x equal to 0, we will get this as 1 minus 1 over 0, which is 0 over 0, which is not valid. So we have to use L'Hospital's rule here. L'Hospital's rule. That means we have to differentiate the numerator and the denominator. Now, in order to differentiate the numerator, we have to differentiate c to the power x. Now, let c to the power x be equal to y. So, x log c is equal to log y. So, now if we differentiate both sides, c being a constant, the left hand side would be log c is equal to 1 by y dy dx. So therefore dy dx is equal to y log c or log c into c to the power x. So therefore we can write the differential as limit x tending to 0, differential of numerator would be c to the power x log c, and differential of denominator would be 1. So now we can substitute the value of x equal to 0, so c to the power x will be equal to 1. So therefore this becomes equal to log of c, and in the given options we can see option 5 is given as log c, which is the correct choice. The next question is a simple logarithmic expression. Log of 4 by 17 to the base 10 plus log of 68 to the base 10 would be what? Now we know log of a to the base 10 plus log of b to the base 10 is nothing but log of a into b to the base 10. So we will use this formula in this expression. So log of 4 by 17 to the base 10 plus log of 68 to the base 10 will be equal to log of 4 by 17 into 68 to the base 10, and that would be equal to log of 16 to the base 10. So in the given option, we can see option 2, log 16 to the base 10, which is the correct choice. In the next question, we are asked to find the derivative of the inverse function of y, not the function of y. So y is given as fx, which is equal to x to the power 5 plus 3. So f inverse y will be equal to f inverse of fx, which is equal to x. Therefore, the derivative of inverse function of y would be d dy of f inverse y, which is equal to dx dy. Now, y is given as x to the power 5 plus 3. So dy dx is equal to 5x to the power 4. So dx dy is equal to 1 by 5 x to the power minus 4, and x to the power 5 is equal to y minus 3. So x is equal to y minus 3 whole to the power 1 by 5. So x to the power minus 4 would be y minus 3 whole to the power minus 4 by 5. So this can be written as 1 by 5 into y minus 3 whole to the power minus 4 by 5. Now in the given choices, we can see that none of the choices match the answer that we got. The first option is 1 by 5 y to the power y minus 3 to the power minus 1 by 5, which is not correct. Next one is 4 by 5, which is not correct. Third one is also 4 by 5, which is not correct. Fourth one is 1 by 5, but it is y to the power minus 4 by 5. So this is also not correct. So none of the above is the correct choice.